Well, hi again, Math 8 students. This is Mr. A. We're going to look at how to find the volume of cones today and also probably do the spheres as well. So we're going to combine the next two into one video because the cones and the spheres really won't take that long to explain now that you kind of got the hang of how to use the formulas again. So from the previous video. So before we do that, a couple of questions here I wanted to throw at you. First of all, how is it come related to a pyramid and how is it come related to a cylinder? And again, if we were in class, we'd spend a little bit of time discussing these. So I'm going to go ahead and just kind of share some insight on both of these. How is it come related to a pyramid? Well, if you think about it, a cone is like a pyramid, okay, except the base is a circle. So the cone, it has a circular base, but it still kind of meets at the top. It has an apex at the very top of it, similar to a pyramid. And how's it related to a cylinder? Well, that's how we get the volume formula for a cone, because really a cylinder is a prism with a circular base. So if you recall from your previous math, the volume of a cylinder was pi r squared h. So you take the value pi times the radius of the base squared, that's the area of a circle, okay, pi r squared, and then multiply by the height of the cylinder. Well, just like last lesson, where you learned that, if I go back up here for a minute, if you learned that the area or the volume of a pyramid is a third of the volume of a prism with the same base, same thing holds true for a cylinder. Let me show you, or for a cone. The volume formula for a cone is 1/3 pi r squared h. And again, this piece right here, I'm going to put in green, right there, okay, that's the area of a circle. So, or area of your base. So it still follows the same format. Area of the base times the height divided by 3. Okay? So the radius is r, so we'll make that the radius of the base, and again, h is height of the cylinder, or the height of the cone. I won't call it a cylinder, my apologies. Height of the cone. And again, it's going to be just making sure we follow the order of operations when we plug in the numbers, and then going for making sure our calculations are correct, putting our calculations in the calculator correctly. So here's our first example. So I'm going to work this one. I'm going to save the second one for you guys to work, okay? But I'll put the answer on there in just a minute so you have a reference. So find the volume of a cone with a radius of 6 centimeters and a height of 15 centimeters, okay? And we're going to use the pi button on the calculator when we do this, and we're going to run the answer to 3 places, so be ready for that. So let's first of all write down our formula. So V equals 1/3 pi r squared h, okay? And it looks like our radius is 6 centimeters. Looks like that is right here. And our height is 15 centimeters, and looks like that's right there. So we'll have our r value and our h value there and there. So we're going to go ahead and put those in our formula. And then again, instead of multiplying by 1/3, we're going to finish this by dividing by 3. That way we get a more accurate answer when we get finished here. And these will be approximations because of the value pi, because we're going to use the pi button to get the best value. You should all have a pi button on your calculator. Use it when you're not using 3.14. Use the most appropriate value. Use the pi button, or if you have to, 3.14159, something more than 3.14 when you do your calculations. Okay? So let's go ahead and set this up, plug in our numbers. So we have V equals 1/3 pi, radius is 6, we'll put that in there, 6 squared, and then we have times 15. Okay? So now we're going to start multiplying this out, and I would suggest doing 6 squared first, follow the order of operations, okay? So we're going to have V equals 1/3 pi, and then we're going to have 36 times 15, okay? So if I go over to the calculator, 36 times 15 is 540. So we're going to have V equals 540. I'm going to rearrange the terms a little bit just to make sure I can get it all in there. I'll put it in the order of a calculator. 540 pi divided by 3. Okay, and from here on out, I don't have to show any additional work. I'll accept it how at this point, however you present it. You don't have to show me the next step because I know it's all calculator work. If you can get it down to this step for me, you'll get full credit for your work on the assessment. Okay, so I have 540. We're going to multiply that by pi. Whoops, I forgot to do the answer key. Answer times pi. Okay, and then you get that approximation, and we're going to do the same thing. The answer divide by 3. Okay, and there is my approximate volume. It is 565. We're going to run it to the 3 places, so it's going to be 0.487 centimeters cubed. Oh, there went my box. Let's try this one more time. There we go. All right, so that's how you find the volume of a cone. You just, again, it's the same process as the last last lesson, just a different formula. So we're going to scroll up. I'm going to let you guys try number 2 now. This is a good time to hit the pause button after I get it in position. And then we'll clear out the calculator so you can see. We start off fresh again. I'm on pause for a minute, and then I'm going to show you how to work the problem out. Okay, so here's the idea. I'm going to go ahead and mark this as h as the height. Now, it's on its side, so it is the height. It just doesn't look like the height, but it is indeed the height of the cone. Okay, but here's the more intriguing aspect of this one. It said that the 6 feet was a diameter of the base, okay? Okay, so the diameter was 6 feet. That's not a radius. Remember, our formula is 1/3 pi r squared h. Doesn't say have anything in there about a diameter. So we have to remember from our previous geometry experience that a diameter, d, is equal to twice the radius. Okay, so if that's the case, then the radius is half the diameter. So in this particular case, if the diameter is 6, then here's what I know. I'm going to go ahead and highlight that in orange here real fast too, so I'll be consistent here. Okay, here's what I know. That the radius then is 6 divided by 2, which is 3 feet. That's the number I'm going to put in for R. Okay? Now I can find the volume. So the volume is going to be V equals 1/3. Let's go ahead and highlight these dimensions again. We have 3 for the radius, and we also have 3 for the height. Okay? 3 for the height. So let's go ahead and put those in. Oops, I was going to color that a different color. Let's try this again. So 3 for the radius and 3 for the height. I went a little too much with the erasing, so I'll put that back. So 1/3 pi. And then we'll put in 3 squared, and then another 3 for the height. Okay? And again, we're just going to work it like we would a regular math problem. So we'll scroll this up just a little bit, so I have a little extra room. And so I have V equals 1/3 pi, and then the 3 squared is not 6, remember it is 9, times the 3. Okay? Now we're going to set this in the format for the calculator. So we're going to change 1/3 dividing by 3 and put pi on the end. So it's going to be 9 times 3, which is 27, pi divided by 3. Now, if you really, really wanted to, you could cancel out, or you could divide the 27 into 3 if you really wish. You could call this 9 pi. But you don't have to do that. I'll accept this 27 pi over 3 for your work, and you just put it in the calculator and get your final answer. Either way, okay? So we'll do 27. We'll do 27 pi divided by 3, just like that. and I get an answer of 28.274. And this is in feet, so it's going to be feet cubed. Okay, and there's your final answer. And just to show you, 9 pi gives you exactly the same value, 28.743. Okay, that's the information about cones. We're going to go ahead now and look at some information about spheres. Okay, so let me pull up what we have here. These formulas are very complex. They involve a lot of mathematics that we are going to take for granted and just call true, that you'll learn a lot more about in geometry in high school. So take my word for this, that these formulas are indeed true, okay? And remember that a sphere is a circular object that is the same distance from the center in all directions. So it has a radius, but that's also like the distance from the center in all directions. So diameter would be considered like the height of it and that kind of thing. What they've figured out is, what mathematicians over time have figured out is the volume of the sphere is 4/3 times pi times the radius cubed, okay? And in addition to finding the volume of a sphere, we also have to find the surface area of the sphere. And the surface area of the sphere, remember, the surface area is the area of all the outside that you can see or possibly visualize. So in order to find the surface area of the sphere, the surface area is SA equals 4 pi r squared, okay? And those are our two formulas for volume and surface area of a sphere. So in theory, you have all the formulas now that you need in order to solve these problems. And I'll have them summarized here after this unit here that I'm in this topic with, and I'll start the next topic with, because we start utilizing this a little bit more and making it a little more interesting in the next video here. So let's do a couple of problems. I'll do a volume problem for you and a surface area problem for you, but I'm going to leave the other two problems for you to do on your own. I'm not even going to show you the answers. I want you to just practice them. Okay, so I'm going to show you two, and then you can do the other two and then work on the practice assignments. So here's example 1. Okay, we're just going to find the volume. We're given a radius. Okay, so I'm going to go ahead and write down our formula for volume. So V equals 4/3 pi r cubed. Okay, and it looks like our radius is 11 meters right there. Okay, so that's going to be our r. So all we have to do is plug it in. So we're going to have V equals 4/3 pi times 11 cubed. Okay, sorry about that. My dog found something outside he was really interested in. So here's what we're going to do. Again, it's all about putting it in the calculator correctly. Okay, so we have 11 cubed. So 11 times 11 times 11. You can do it that way and get 1,331. Or if you want to try a little bit more sophistication, you could do 11. And right here in the middle, top row, a to the b power, that's your power button, 11/3, 1,331. Okay? So either way you get 1,331 for 11 cubed. So volume, we're going to put this in our calculator format now. The 4 is going to stay on the top of our fraction. So 4 times 1,331 times pi, because we want to do pi at the end, all divided by 3. Okay? So as long as you show me this step right here, that's fine. You could also multiply 1,331 times 4 if you want to, and give me that number. That's fine. Give me 5,324 if you want to. So 5,324 pi over 3. That's also fine. Okay, if you want to do that. You don't have to do that. If I see this value right here, okay, that's going to be okay for me for your work, because I know now that you showed the correct order of operations and you're good to go. All right. So let's go ahead and start working on this. So we're going to take 5,324, multiply. Whoops. Let me back up here a little bit. Multiply by 4. Answer times pi. Divided by 3. Oops. Answer divided by 3. And as you see, we get a final volume of 5,575. We're going to round that to 3 places of 0.280. Whoops. I accidentally hit my scroll bar. Okay, 0.280. And that's the final volume, so I'm going to put the unit underneath it. And if I remember correctly, it was meters. So 5,575.280 meters cubed. Okay? So again, it's just all about making sure you plug in the numbers in the right order into your calculator and getting the right volume. Okay? So order is important. Follow the order of operations. Change it to a division problem so you can divide by 3 appropriately, okay, and accurately. And that's how you find the volume of a sphere. Okay? It's the same process. It's just a different formula. All right? So here's what we're going to do. I'm going to clear this out on my calculator. We're going to skip the next one. I'm going to let you work that one on your own. Just note that, if you see here, note that it has a diameter. Okay, so be careful of that. We talked about that just a little bit ago. Okay, we're going to go over here to a surface area problem. In fact, I'm going to save 3 for you to work because it's the same radius as number 1, so you can find the surface area of that one. We're going to do surface area number 4. Okay, this is the same diameter as the one we just skipped. So I'm going to go ahead and mark the text. I'm going to mark diameter there so I know to change it. Okay, so remember, the radius is the diameter over 2. So that equals 9 over 2, which is 4.5. Okay, and remember also that we're going to find the surface area. So the surface area is 4 pi r squared. No fraction this time, so that's a plus. Okay, so the surface area is going to be 4 times pi times 4.5 squared. Let me go ahead and color code this just so we understand. Color code it in blue, so we're consistent. I'll go ahead and highlight it in blue here so we know it's the radius. Okay, and then we know that that number goes in this spot right there. Okay, now follow your order of operations. Square 4.5, multiply it by 4, multiply it by pi. Okay, so 4.5 squared, 20.25. Okay, multiply that number by 4. Whoops, answer times 4. 81. So let's write this out before we get ahead of ourselves here. So I have the surface area is equal to 4 pi times 20.25. Okay. Then let's multiply by 4. You get 81. So then the surface area then would be 81 pi, or 81 times pi, and that then goes in the calculator. And then multiply that by pi, and you get 254.469 inches squared. And I don't know if I mentioned this on the first video, but I'll mention on this one. We will tell you the units for your answers. You don't have to worry about units, but you have to make sure you follow the other directions. Use the pi button, 3 decimal places, okay, in your final answers. And this is going to bring this video to a close. I'm going to let you do the rest of the examples, and you can work both now, Section 8.2 assignment and the Section 8.3 assignment with this video. So if you have any questions, feel free to drop a line, an email message. I'll be glad to help you. Otherwise, I'll have one more video to do, and I'm going to get it done, and I'll see you guys when I see you.